Hello, everyone. Today we're going to use data from CoAgMet to calculate growing degree days for thermal time analysis of crop growth and development. And we're going to use AI, especially CoPilot, here to help us do that. So we already know if we go over to a website thinking about what growing degree days are, right? They're a very practical, empirical method for mainly producers to track the rate of development of crops, right? That's how we use growing degree days. Also, entomologists use it to track the growth of insects, and there are some other uses. The main principle being that biochemical reactions are temperature dependent. So the warmer conditions are, many biological organisms will develop faster, grow faster, go through their life stages quicker. If it's colder, that suppresses growth, right, and development. And the little practical tool that agronomists have developed a long time ago was that they just took the maximum and minimum temperature from weather data and they could use that to calculate a growing degree day for each day. And it's like some people describe it's a way of sort of um, correlating thermal time or thermal rate of development with your date and time that we operate on, right? So if you look at some example calculations here, if you got a maximum of 80 degrees F and a low temperature of 60 degrees F, and corn has a base temperature of 50 degrees, your mean temperature would be 80 plus 60 divided by 2, or 70 degrees. And then to calculate the GDD, it's 70 minus 50, or 20. So for this particular day, you would get 20 GDDs, right? Now you have to cap the maximum and minimum temperatures. So here's a different day where the temperature was 75 and the low was 45. Corn base is still 50. Now, what you see is that he rounded up this 45 degrees up to 50. Like 50 is the lowest you'll let it go. So it's 75 plus 50, right? Gives you 62 and a half. And then the same thing can happen on the high end. If it's too hot, 93 in this case, the corn cutoff temperature is 86. So you can see there that he reduced the maximum, didn't use 93, used 86, right? And so that came out as 80. 80 minus 50 is 30, right? So there's a lot of websites on how to calculate growing degree days. So I won't belabor that too much. I'm more interested in showing you how we would do the calculations. So let's go over to CoAgMet API Builder. We've already been here for several other projects. So the data that we need to calculate growing degree day units is maximum and minimum air temperature in degrees Fahrenheit. This is one of the very few times we'll use English units to do some kind of calculation. And what I would like to do in this example is compare two locations. I want to compare Greeley, Colorado to Lamar, Colorado. So it's about over 200 miles difference between those two locations. One's in the southeast corner, one's more in the north. So there should be some differences in growing degree day units caused by temperature. So we go to our API builder here and we want to pick by date. We want to pick CSV. We're going to do multiple sites this time because we want Lamar and Greeley. So I'm going to pick Lamar, which is LAM3. Okay, I'm going to click on that. It'll turn blue when you click on it. And then I'm going to scroll up to find Greeley 4. And I'm going to have to hold the control key when I press it. Okay, so the ones in blue are what are part of your analysis. So see, Lamar 3 is blue and Greeley 4 is blue. Let me do that again because this can mess you up. I'm just going to click up here. See, nothing is blue. That means, well, let's see, Lamar is still blue. There, hold on. So Lamar 3, I'm going to click on it, go up to Greeley, hold down the control key, click on there. Now they're both selected. Okay. And then we want to go over here. We want to include the header information. We want to be quality controlled. Here we're going to go with US units or English units. We want daily data. You'll probably have to change this, right? You want to go to 2025, May 1. So 5/1/2025. And then change this to the end of September. Okay. This date format, in this particular case, let's just leave it as the default. It doesn't really matter in this case. Time zone is okay. And then our daily fields, first I'm going to say check none to get rid of everything. And then I'm going to pick the maximum and minimum temperature, air temperature. That's really all I need for a GDD analysis. Okay. And once that's done, looks okay, I can say open. Okay, and I can take a quick look at the data. Here you can see it's the Greeley data first and the date and the maximum min temps. And if I scroll down a bit, here's the Lamar data, also starting on May 1 and going down to the end of September. So that looks good. I'm going to hit Control S, and that'll bring up my Save As page. So Control S. And I'm going to save this in my, I think I'm going to put this in my, let's see, I'm going to put it in my downloads folder. And I'm going to give it a name so I can sort of recognize it. I'm going to work with GLY03 and, well, let's see, GLY04, excuse me, and LAM03. Those are my two sites. And it's temperature data for GDD. That sort of gives me a rough idea. And make sure to change your subscript to CSV, comma, separated variables. Okay. And I'm going to save that. Okay, so I've got the data that I need now to do the analysis. Now we need to go to the AI and ask it to do the analysis for us, right? We could paste this into Microsoft Excel and try to do the analysis, but let's just try to use the AI and see how it works for speed purposes. So we're going to use CoPilot, which is the AI that you have available as a student, right, for free. Remember, if you always forget where this is, you can go up to your browser and type in something like CSU AI Tools, and it'll show you like AI Tools, Colorado State University. And the one that you want to use is this Microsoft Copilot chat. Okay. And it says when you're logged in with your CSU ID. Okay. And there you go. And you can see we're in the Microsoft M60, 365 cloud. So there we go. So we just need to decide what kind of prompt we need to put in here. First things first, though, we need to give it the data. So I'm going to hit the plus sign, upload images and files. I'm going to go to my downloads folder because that's where I put things. And there's my file. So I'm going to click on it and hit open. You can see it appear right there. Okay. That's the one that we selected. Now I need to build a prompt, okay, for this. And I've already written one for you. And let's go over this really quick because the writing the prompts is really the key to getting the AI to accomplish the task you set out for. Okay, so the prompt that I wrote was attached or maximum and minimum air temperature data from CoAgMet for these two locations from May 1 to September 30th. I tell it the format that it's in. You can see here I said it's name, station name, date and time, maximum min temp, and told it the units. And told it there was two header rows on the CSV and one of them is units. You can just skip that, right? So that's sort of the first paragraph is describing the data. Then I tell it what I want it to do. Calculate growing degree days for both locations using a base temperature of 50. And then I said use a 50-degree limit on minimum temp and an 86-degree on max as normally done for corn. And then I want it to calculate the growing degree day for every day between May 1 and September 30th and also calculate cumulative growing degree days over that entire time series, right? Because That's what we do with growing degree days, right? We want to see how many units it takes for it to reach a certain point, right? And that will be an indication of physiological maturity, reproductive state, all those kinds of things. And then I said, make a line plot of cumulative GDD for each location on the same plot with the y-axis as cumulative GDD and the x-axis as date, and include a legend. So I want it to create a plot that's got two lines on it, one showing Greeley, one showing Lamar, right? And then finally, I want it to create a report. That's what this final paragraph is. That includes the cumulative GDD plot and a table showing when they exceeded 1400 GDD. Remember, that's about soaking and pollination. And when it reached 2700 GDD at Lamar, that's physiological maturity for varieties planted down there. And 2500 at Greeley, that's for varieties planted farther north. And, and then I give it a little bit of information that I want it to be in the report, and otherwise keep everything very concise. Sometimes I'll say that, keep it concise, because some of these AIs will just add stuff to your report that you don't want. Now, I put this paragraph right here over in Canvas in week 3. So it's right here, AI prompt growing degree days, right? So you can download that and modify it to help you do the problem. So here you go. So I'm going to go over to my Word document. I'm going to copy this, and I'm going to paste it in there to the AI. So if you look at your chat box, it should have the attached file name and your instructions. And when all that's done, you hit go. All right. And so you'll see the AI working. And sometimes this takes a little while, depending on how complicated the problem is, or how busy the AI is, or what level of account you have, right? We're using the free one that's provided with our Microsoft 365 account. But you could try doing this exact same thing with other AIs. And I had pretty good luck using Claude. I tried it with this and it worked pretty well. You can see it's calculating GDD, adjusting max and min temp, reworking the data, and just working through the problem, which is kind of fun to watch sometimes to see what happens. It gives me some reporting saying what it tried to do. And there's my curve. And, that looks pretty good, right? I would say it did a pretty good job of formatting. It says cumulative growing degree days, date goes from May 1 to October 1. That's what we expect. It's got the legend. It's got two nice plots with Lamar generating more GDDs than Greeley. That's exactly what we would expect, right? Because it's warmer down there in Lamar. And so it has a different GDD curve. And then it made my little chart that we wanted for silking and maturity. It says at Greeley, it got there at the very end of July for silking and pollination. And at Lamar, it got there a little bit earlier, if they planted at the same time. So remember that. We assume they planted on the same date. That's probably not going to be true. So you'd have to make some adjustments in the real world. And it said over that entire period, we got over 3,000 GDD from Lamar, but only 2,500 from Greeley. Okay. So, hey, that all looks pretty good. And it gave a few notes there. So here's the report that it generated. And so you click on that and double click here. Let's take a quick look at it. And here's what we've got. And it looks pretty nice, right? It's pretty concise. It reported the growing degree day units. It gives us a little information reminding us what year we were working in and what stations we were working with. It tells you the method that it used. It gives that nice plot, and then it shows the little bit of the some of that phenological thresholds that were surpassed. So nice report. So you can see that it was, I spent a lot of time here talking. If I wouldn't have been talking and just tried to do this as fast as possible, it would not have taken me very long to generate this report, right? All I really needed to do was one, download the data from CoAgMet and then give it that prompt, right? And to CoPilot, and it generated this report, right? And so this is great for when you're trying to make these kind of decisions or doing some kind of what if analysis, right? So this is a really powerful tool that's often used by farmers and producers, and that you can leverage that now using AI as another tool in your pocket that you can use.